But let me go through the conic sections that we are still working on. So now we have done the ellipse, so the parabola ellipse. Okay? And the next one is the hyperbola. So I'll overwrite the definition first. It's similar to ellipse, set of a set of all points. All points in the plane. The difference of whose distance from two fixed points. The two fixed points is the focus 1 and focus 2 is a constant. So from ellipse, it's the addition of the distance and it's equal to constant. But now it's the difference, meaning the subtraction. Okay, the F1 and F2 are foci of hyperbola. So let me draw the hyperbola. Imagine this is the hyperbola. This is y-axis. Let me write this is F1 and this is F2. And maybe we have P, okay? At some coordinates. The F1, the coordinates is the C. It's similar to ellipse. So C will be related to the vertex. Okay, now we have this line. So the constant, so P F1 minus, wait a moment. Okay, please wait a moment. Okay, hopefully it's not crashing again. Okay, so the definition will be the PF1 minus PF2 is plus minus 2A. So the distance PF1, we can simplify this to square root x plus c squared plus y squared minus is equal plus minus 2A. Let me copy this to another slides. Okay, so the difference in ellipse and hyperbola is this. In ellipse, PF1 and PF2, if you plus them, it's constant. But in hyperbola, this PF1, PF2, the constant will be up here when you are subtracting the PF1 and PF2. Okay. Now let me get to the other page. So this is equal plus minus 2A. and then simplify. Okay, meaning you remove the square root, you square both of them, and then simplify. Simplify, and we get the c squared minus a squared, the same as we did with the ellipse. And then divide all by c squared minus a squared. It's become 1. And the b is appearing from c squared is a squared plus b squared. The same as ellipse. Okay, the difference is now it's having a minus. Okay, so in this case, the x-intercept is plus minus a. Now we will move further to distinguish the hyperbola. So first, the formula. Okay. The first one is equal 1. A is greater than 0, B also greater than 0. The other one is you switch the x and y. The vertices, this one is plus minus a, 0. And the other one is 0 plus minus a. The transverse axis, the left one is horizontal. It's 2a, the length, and the other one is vertical. You will see what the transverse axis means if I draw. Okay, but let me write first. Okay, the asymptotes. I think I can make this going up. Okay, the asymptotes. The left one is you have 2 asymptotes, and the other one, or let me just write plus minus a over bx. That's much simpler. Yeah. The asymptotes, the foci, this is plus minus c, and c is from and this is same definitions. And the graph. The left one, same as we seen from the previous graph. Okay. This is f1, f2, and then This is negative A. This is A. And let me make the hyperbola looks more smooth and logical. Okay. Maybe a little bit lower. Okay. Okay, now the B is here. Okay. So in ellipse, your A and B is based on the length, the vertical and horizontal length of the ellipse. In hyperbola, you have the hyperbola in both sides like this, and you have the box in between. Okay? The box is actually not there; it's imaginary box. Okay, but the sides is the same as A and B. Okay? So this is A, this is A, this is B. So the whole thing is 2A and 2B. Okay. And the asymptote will across this box. Okay. So the proper way to draw this hyperbola, either way, you can draw the asymptote first from the B over A. If you know the formula, the x squared over A plus y squared over B. You can draw the asymptote from B over A, x, the positive one and then the negative one. And then draw the rectangle with the sides 2B and 2A and 2B. Okay. After you draw the box, then you can draw the hyperbola. That's the proper way to draw the hyperbola. From the asymptotes, and then draw the rectangle, and then draw the hyperbola. And how to draw that? You need to know the A, okay? And then later you need to know the C here. You can see from your A and B, A squared plus B squared. And that's the hyperbola for the first form of hyperbola, the left and right. The other form is top and bottom. Okay, so let me draw the other one. Now this is A, this is negative A, and B, negative B. And then this is the F1, the 0C. This is the F2. And the asymptote will be A over B. And this one is B over A. So the same principle. You begin with the center. Begin with the asymptote. And then from the asymptote, draw the rectangle. Now it's 2B here and 2A here. And then draw the hyperbola and then draw the C. At least, okay, at least the hyperbola is correct if you mention all the key points like A, B, the C for the focus, the asymptote. Okay. I think for me, if you just mention the focus, the A, B, that's okay. That's okay. Unless the question is asking specifically to mention the asymptote. For me, if you just draw the rectangle and then hyperbola, that's still okay. Because you already have all the necessary points, the A, B, and C. The asymptote is important if you want to make the exact shape precisely. Okay. And the focus, okay, if you want to make a really, really exact, precise hyperbola, you can make this point and then mentioning the distance here and distance here. So the distance from this point, the other hyperbola point minus this point is 2A. Unless you want to calculate that, then for me, just make the sketch illustration roughly, that's fine. Okay. Now all the conics we have now, okay, the hyperbola, the ellipse, the parabola, the hyperbola, all centered in the, at least for ellipse and hyperbola, all is centered in 0, 0, right, in origin. We can have the center shifted, okay? I believe I mentioned a simple equations about ellipse in the yesterday's quiz. If you are familiar. Let me write the equation. I believe the equation yesterday is 2, right? Sine t. And y is what? 4 plus cos t, right? Okay. I will tell you, this is an ellipse. This is an ellipse. And how to make it ellipse? How to rewrite the form? This is actually one of the, I think, very basic standards polar to rectangular or rectangular to polar examples. Okay? The idea, if you see sine and cos, imagine sine squared, if you have squared, plus cos squared is 1, right? So let's make that happen in this form. Okay? If you still make mistake in this kind of questions, the next calculus, the calculus 2, will be difficult because you will be introducing with the parametric equation, the polar curves at the very early semester for calculus 2. So let me write the sine t as x over 2, okay? And cos t is y minus 4, okay? Let me both squared, squared, all squared, okay? And then just plus this. So this will be 1 equal. Let me just square x squared over 4 plus. No need to expand, okay? No need to expand. This is an ellipse. You have, this is, the length in x is 2, this is 1, the length is 1. So you have an ellipse, but different center. It's an ellipse centered at 0, 4. Okay. So the way you draw, you can draw so 0 and maybe 4 is maybe here 4. So this would be the center of the ellipse. In the x-axis, the length is 2, 2. So 4, the distance is 4. So maybe this 2 is here. And 2 is here. And the length of y is 1 here and 1 here. So if I drew the complete ellipse, okay, if I drew the complete ellipse, it will be like this. Okay, it will be like this. But the question is, you have t is from, I think, pi over 2, and then 3 over 2, right? What will happen from pi over 2 to 3 over 2? You only have this motion. And stop here. So that's what motions means. So you draw this, and then just making the arrow. Let's describe the motions. The arrow. So it's telling you that the graph is moving from this point to here. That's to describe the motions. I'm expecting this to be an easy question, but and then I just gave it, okay, just maximum is 8 points, but most of you are not getting it. So okay, please remember this, okay? And then the other one is also important in shifted. I also gave in yesterday quiz or p sign. This, right? I give you this, and the question is mentioning that it has somewhat related to circle equations. Okay? And how do you make the circle out of this rectangle? First, remember the circle is from x squared plus y squared is equal r squared. Okay, you see squared here, right? And maybe you in your mind, okay, maybe we are squaring this off. So r is become r squared. But in the middle, or in the whole equation here, you will get expansion of this, right? How about just we are multiplying with r? That would be better. Because it will be AR and it should be R sine, right? So R squared, AR cosine theta, and then BR sine. Okay, now R squared is x squared plus y squared. Okay. R cos theta becomes x. Okay. And this become B1. I think some of the students you're getting here, you are confused. What should I do after this, right? Come on, it's x squared ax combined here, y squared by combined, and complete squared. Do you understand what I mean? Complete squared. Okay. Here, x squared minus ax. Okay. And then plus y squared minus by. Imagine these sections, and these sections, these are quadratic functions. If you complete quadratic functions, let me divide a by 2 and then square. Let me plus here. Okay. So if I plus half a squared and this plus half b squared, the other side I need to plus 2, right? Okay. I can do this, right? I can plus half a squared, and then this is also half a squared. Equal, right? Half b squared and half b squared. Okay? This becomes x minus, agree? Okay? And then plus. Okay, and this will be 1 over 4. I just write the value. Okay. So the center of the circle is half a, half b. The center, not in the 0, 0. Okay. And the radius is square root of or you can solve it maybe this, either this or this. No matter, same function. So this is the answer, and this is also shifted. Okay. So if you see any x minus, then the center is changing. Okay. And how you draw also change. So if you need to like sketching some form of conic sections, if you see any minus or plus in x and maybe in y, then you need to shift x and y into the position, and the center will be shifted. So if you have the So if you have this, it's ellipse, but it's the center is H and K. So meaning, okay, how you deal with the sketching of this curve is you start from shifting the center, and the A and B will be you draw A and B from the center. Okay, the distance is changing. Okay? Or the other way, you can just ignore this at first glance. Draw the normal version of ellipse, and later shift it to A to K. That's also fine. You can also do that, and maybe that's even faster. Okay, so maybe you start by drawing the ellipse. Maybe this is your ellipse. Okay. So maybe this is your ellipse. You draw at the center of 0, 0. Okay. Now you know you have HK, but this distance here is the same property, right? The same shape. What you need to do is just shift this into your HK. Maybe maybe it become here. Maybe it's shifted from 0, 0 to HK here. Or maybe somewhere else. This is just illustration. Okay? It depends on the exact coordinates. Can be here. Okay? So that's the shifted. Okay? And also hyperbola, you can do that also. But I think it's more. What you need to do for hyperbola is do not focus on the hyperbola, but focus on the box. The box at the middle. Here, the box here. Instead of looking at this hyperbola, because if you're looking here, probably will get mixed in your mind. But it's better if you focus on this box. Okay, this box. So draw the box, and then shift the box, and then draw the hyperbola. That would be, I think, much more easy. Or so two way around. The first one is we shifted the points of the center points, and then draw the box. Or you draw the box first and then shift it. Both ways the same results. Okay. I need to add some additional notes of the shifted. Okay. Notes. So from the shifted conics, so let me start from here. Okay? Look at this x minus 8, y minus 8. If you think any number and then expand the equations and then maybe do some manipulation of the form, probably you will get like 9x squared plus blah 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 y squared plus blah blah blah, and then it become all that really long equations. Okay? So this is the general equation that we can get out of the shifted conics. Okay, is general equations. Okay? If you expand and then simplify the form, so when the A and C are not zero, of course, you will get conic, or sometimes you will get it's called the generate conic. What does it mean is it's almost conic, but it's not conic. So when you try to simplify, you cannot get whether it is ellipse, hyperbola, parabola, you cannot get out of the shape from the generate conic. So when you are finding those equations, and you cannot think anything else, then you can just conclude that, okay, that's the generate conic. So it's a conic, but you are taking something from the conic equations. So that is incomplete. Okay? Maybe it's also a fine terms. Okay, so incomplete conic. And then for non-degenerate case, okay. So if we are looking in general conic case, okay. Parabola, if A or C is zero, not both. Okay, of course, right? If you have y squared and x squared, one of them is zero, then for conic case, it will be parabola, right? And then if it will be ellipse, if A and C have the same sign, positive or negative. Circle, if A is the same as C, it's hyperbola. If A and C have the opposite sign. Okay, so I think for ellipse and hyperbola, if you understand the formula, it's ellipse, you have x squared plus y squared, right? A squared over A squared plus y squared over B, right? It's plus. So meaning the x squared and the y squared should be having the same positive or negative sign, right? And hyperbola, it's x squared minus, right? Or y squared minus, depends on the formula. But the A and C should be in positive or negative and positive, or positive negative, opposite sign. Okay. I think this is intuitively correct if you imagine the formula of all the conic sections. Okay. So I think the content for the conics is just up to here, which the conic section in general, how to sketch the conic, the shifted conics, you move the conic section, and then if you have the long equation for conics. Okay. The next one for the conic that I can give you is a practice, but I think I will give you some practice. Maybe I will attach in the Moodle system. You try some exercise from the textbook. Later, if we still have time, I will maybe mentioning some necessary practice for you. But now I think we can move on to another chapters. So conic sections, all is just that. I believe it's also the same case if you have learned before. Have you learned before in high school for conics? Who doesn't? Who hasn't? No? No? Really? Ellipse, hyperbola? No? Okay. Okay, maybe I will give you practice, but later. Actually, there's additional notes for the conic sections. But I don't think we can deal with all the conics. So I think for conic I will stop here. Actually, there are another section for conics that is we learn about shifted. The other one is actually you can rotate the ellipse or the hyperbola. So rotations of conics. But I think I will skip that for now. I will, and maybe if we still have time, maybe we can add in another session. And also, the other section for conics is the polar equations, but I will skip for now. Because you will learn eventually in calculus. So now I will stop here for the basic conic. The next conic will be I think in the next calculus will be conic section. Actually, we still have factors, but I will not start the factors. Have you learned factors from physics? Physics? Right? Learn factors, right? The factors? That's, yeah. No. Before you learn force. Yeah.
Vectors.
Huh?
Vectors.
Yes.
Oh, yeah.
Learn, right? So I will not start now with the factors. Rather than that, I will start with system of equation and equalities. So let me write the chapter first. So this is chapter. In the textbook, it's chapter 10. The conic is actually chapter 11. So this is chapter 10. Let me write the title is System of Equations and Inequality. So first, what we are dealing is systems of linear equations. I believe this should be easy, so I just reviewing. So, of course, we already learned how to find the solution. Right? Okay, I have these two questions and solve x and y. How many minutes you can solve this? You can have substitutions, right? Or eliminations, right? And then maybe another way is through graph, but this takes time. Okay, to graph and then see the x and y. I believe if you have only two variables like this and it's simple enough, I'm not sure which one you prefer, but for me personally, I'm choosing the elimination. You have two here, maybe you can make it 2, 8, 14, and then minus. Okay, try how many minutes you can. Because actually in calculus, you are not doing only calculus, right? There are parts in calculus that you need to know beforehand, like the algebra. And the algebra is by means is how you are solve any mathematical equations in terms of algebra and how fast you do that. How many methods you can have. Okay. That will also considered as one factor in the calculus algebra. The calculus part for the calculus in this semester is only the integrations and derivative. That's the calculus one. The other how to solve, like how to rewrite the equations, how to make how to solve and maybe change the equation in another form. That is totally the algebra part. Okay? I think what you are lacking is the algebra, and and you need to enhance your skills. Okay? Because if you are just learning only like okay calculus and you know the concept, it's not enough to solve the whole calculus problem because you need to know beforehand the algebra. Okay, how many minutes? Hmm? Yeah, okay. Yeah, good. It's actually easy number, right? Easy number, easy to calculate, right? Can you solve it? So for the standards, you need to solve this at least in under than 1 minute. Okay? It's too easy. Okay? Still calculating. I'm not sure if you are going forward to the next year, the third year. I'm not sure you will be survived. Okay? So this should be in at least 1 minute or under 1 minute. So yeah, it should be 3 and 1, right? The other, okay, the other example. Let me write some equations. This is basically you have a y. Sorry. This is for the equation that have solutions. Okay? There are others. Um, Let me write the 8x minus 2y equal 5. Okay. Can you solve this? So linear equations is actually a good way to introduce you to linear algebra. Linear algebra is actually another specific course in terms of math, okay? And that's the base on programming. If you want to enhance your knowledge of programming, you need to know the linear algebra and start from linear equations. Did you see? If you think to solve this like substitution, elimination, like in your head, right? It's like imagine you have your machine and you can teach the machines to do like you did, like maybe substitute, and that's the way of programming. So the way programming is start or works is based on the linear algebra, and the way you start the linear algebra is from the linear equations. So what's the conclusion? Weird, right? Weird results. Right? So this is let me write here. Linear system with no solution. We can say this is a linear system, but it's not. We don't have any solution for this case. If you try maybe multiply by 3, multiply by 2, and try to plus, you see, it's become 6, it's become 6, and it's become 0. No solution. Okay. Another example is 3x. Okay. Can you solve it? What will happen now? The previous case, you can have 0 is equal to 29, right? And what will happen here?
If you graph those, I think they're parallel. If you graph these two,
Yeah.
they're parallel.
Yes. So the conclusion for this one is the previous one is no solution. Now, infinitely many solutions. You can have many solutions. So we can write here a linear system. And if you are trying to solve this, maybe multiply by 4, this multiply by 3, 12, 12, 24, 24, 48, 48, right? And if you try to find, okay, maybe I'm eliminating this, it all becomes 0. All becomes 0. So there's 0. So if this happens, it's having many solutions. If this happens, no solution. You can actually draw the graph to see what is actually happening. I think that is the most important case in the linear equations. So, oh, this is the system. So you have a solution, no solutions, many solutions. And I'm the linear system is the easiest method to be modeled. Okay? So if you have like a case, and you can model by linear equations. That's the model that easy to approach. And how to model is you take x and y as variables. Maybe when you purchase something, you want to know the maximum number you can purchase. This is the item that you can purchase, and maybe you can have more than more than two variables, maybe x, y, z, and more than that, maybe 5, 6. As long as it's still linear, it's not polynomial. As long as it's linear, you can solve with substitutions, eliminations. Okay. And when you get this situation here, then you can conclude that which one is solution. No solutions, or it has infinitely many solutions. I will skip this, Okay. The other way to solve the linear equations is through the matrix system. Who haven't learned the matrix? Matrix. Do you know matrix? Matrix, you know? Learn before? Learn matrix? Okay. Okay. So the next section in the system of linear equations, we will learn the matrix. So I will write the matrices. If I have 2x minus y equal 5, x plus 4y equals 7, this is what we call the linear system. And this is what we call, before we learn the matrix the traditional way, I will show you the other form. We can write this equation. This is called the augmented matrix. So actually this is x, this is y. Okay. This is x, this is y. And this is the result. So it's actually having like that. But the way you write the augmented matrix is just this column, okay? 2, negative 1, 5, 1, 4, 7. That's the augmented matrix of the system. Okay? So definition of matrix. Let's say this is M. This is N. This is M row. And then this is N column. So M matrix is rectangular array of numbers with M rows and N column. So Aij, we say this is the entry of matrix. So the I is row, the J will be the column. Or when you see here, 1, 1, 1, 2, 2, 1, 2, 2, 2, 3, 1, 4, 1, okay? 1, 2, 2, 2, 3, 2, 4, 2, okay? And then the other one, 1, 3, 1, 4, and so on. 2, 2, 2, 3, so on, okay? So that's how you are inputting the entry number for HA. But in real case, in the application case, it's just a number. It's a number. And I think for this course, maybe we will only learn the two matrix and maybe three matrix, triple row and column. Okay. Let me give you an example, and then I will give you how to solve. Okay. Really good solutions, and maybe it will be uh, good for you if you want to learn more about the linear algebra, especially for programming. So if we need to write the augmented matrix, we can write 6, -2, -1, and 4, and then 1, 0, 3, 1, 0, 7, 1, 5. And this is the augmented matrix. How to solve this? Basically, if you are just using the substitution eliminations, you can do it, right? It's doable if you want to run. But when you are dealing with this augmented matrix, there is a system or the method called the elementary row operations. I'm not sure whether you will learn in the engineering of math or no, the elementary row, but I was learning this when I was studying the engineering math. Okay? So you have an augmented matrix. Elementary row state that uh, first you can add a multiple of one row to another. And second, you can multiply a row by non-zero constant. And you can interchange rows. So you can move this down here, move up. The idea is you can multiply with anything here. For example, you see 1, 0, 3, 1. Okay, you have 0 here, and the other one 0, 7, 1. Okay, if I multiply the bottom with 3, let me write 3. This becomes 21. This becomes 3. This becomes 15. Okay, and this 3 and 3, I can subtract this or this can subtract it, or this can subtract it. And I can rewrite maybe 1 minus 0 is 1. 0 minus 21 minus 21. 3 minus 3 is 0. 1 minus 15 is negative 14. But anyway, you can do whatever you want. Multiply with any number. You can exchange this, okay? And whenever you find 0, 0, number, or number 0, 0, number, or 0, number, 0, number, you will find at least one variable correct. And from that variable, you can just exchange all, and then you get the solutions. Okay? That's the first thing you can do with the elementary row. Okay? I will show you another way to look at the system. Okay, let me give you another example. I think this one, the number is not really good. Let me give you x minus y plus 3z equal 4, and x plus 2y minus 2z equal 10, and 3x minus y plus 5z equal 14. So we can write the augmented matrix: 1, negative 1, 3, 4. 1, 2, negative 2, 10. 3, negative 1, 5, 14. Okay. Look at the first row and the second row. I will minus the top one to the bottom. Or you can do the opposite. But I will do the top one, subtract the bottom one. So if this is, let me mark this as R1, R2, R3. So R1 is still the same. I'm just writing the R1. But R2, I can write this. So 1 minus 1 is 0. 2 minus 1 is 3. Negative 2 minus 3 is negative 5. 10 minus 4 is 6. And then maybe the row 3 is now I see either row 1 or row 2, it's have 1, 1. It's 3, right? So I can multiply this or this by 3 and make this 0. Okay? So let me write this as 3R1 minus R3. So 1 multiplied by 3, okay. 1 multiplied by 3, 3 minus 3, 0. Okay. 3R1, negative 3 minus 1, so negative 3 plus 1 is negative 2. Or maybe let me write R3 minus R1. It will be the same. If you can write like switch R2, R3, R1, should be the end result should be the same. If you consistently plus and minus in the correct way, it should be the same. So let me write negative 1 plus 3, 2, 5 minus 9 is negative 4. 14 minus 12, it's 2. Okay. So now we are doing in at least we have 2 0 here. You know what's the idea behind of what I'm doing here? I will try to make this part is 0. At least this part. If I have this 0, then I can solve easily. So let me write another augmented matrix. The R1 is still the same. R2 is still the same. And I will write R3 multiplied by half. So 0, 1, negative 2, 1. Okay. Another matrix. The first one is still the same. The second one, R2 minus 3R3. Meaning this is from the previous one. So R2 is here, minus here. Okay. So R2 minus R3, the first one is still 0. R2 minus 3R3, so we have 3 minus 3, so it's 0. And then negative 5 minus plus 6, right? It's 1. 6 minus 3, it's 3. And keep the same at the bottom. And I can exchange the 0, 1, negative 2, 1, 0, 0, 1, 2. So I can exchange the R2 and R3. So when we have 0, 0, 0, this is actually what our goal is. We need to make all the matrices We can exchange, we can multiply with other constant, we can, actually you can do almost everything. Like you can maybe this column, this row you want to multiply with other constant and plus this, or maybe minus this. You can do whatever you want. And the idea is to get 0, 0, 0. So it's simply the z will be equal to 3, and because it's 3, then it's -6. So y minus 6 is 1, so y is 7. And then you are doing the same, y is 7, z is 3, you plus this, and you need to get 4, you get the x. And if you are doing with the correct addition, subtraction, correct multiplying, and you get the 0, 0, 0, I believe it will be very fast. This method will be very fast to solve like all the linear equations. This is 3 variables. You can also do like 5, 5, 6, 6. With the same concept, making 0 and make the last one here have the number here, exactly the number here. But remember, if you have, maybe this becomes 0, 0, 0, and this is a constant, then there is no solution from the previous one that I gave you. Or if you have, maybe when you're dealing with the calculation, you have 0, all 0 here, then infinite solution. Okay? Same concept. But if you get like 0, 0, and a number, then exactly you have solutions. The z is 3, and then this y, you get the x. Okay, that's the first method that I think you need to at least try by yourself. If not, then you will be lost. Okay. I will give you later some practice to check. Another way, that's the first method to solve. Another way is you can make this 0, and you can also make this 0. So 0, 0, 0, and 1, 1, 1, 0, 0, 0. And that's exactly what your computer did. Okay. That's it's called the Gaussian method, Gauss method. So you see here, this first row and the second row. Okay. You can imagine the first row, and then you want to plus this. This becomes 0, right? And this becomes maybe what? 1, right? So it's 1, 0, 1. You know, 1, 0, 1, and then some constant there. You can do some manipulation form one more time, and you can get 0, 0, 0, and exactly you will get x, y, z. One solution, one solution, one solution. You can do that also. Okay. I hope you can try some practice later. I will finish the class by this the augmented matrix. Okay. So this is called the elementary row operations, in which you can manipulate your matrix. Okay. You can multiply by 3, by 4, by 5, any numbers you want. The idea is making this 0, 0, 0, or 0, 0, 0, 0, 0. And it should be 1, 1. Or maybe you have 2, and you need to just divide by 2, and it's 1, 1, 1, and that's the solution.
So it always has to be 1, 1, 1.
Of course. It can be 2, but you can divide by 2, right? It's become 1. Okay. So if you want to make sure that it is exact, so the exact solution, so this should be 1, 1, 1. But believe me, if you don't try this by yourself, the calculations, you will not understand what this is about. So my point is, maybe you can start solving this by yourself and do not see the solutions.
solving by your own idea. Because the solution is not exactly like that. You can have many methods. You can exchange form first. You can maybe multiply with other constant, and maybe you want to subtract first. And you know, sometimes when you see the like 1, 1, it's obvious, right? This should be at least this row or this row should be 0. You can minus this R2 to R1 or R1 to R2. Both are okay. Both will be 0, right? And you can do both ways. The result should be the same. The result should be the same. So you can do minus, you can plus, you can multiply first. Maybe before 1, maybe you want to multiply by 3, then you can subtract this first, make it 0. But one suggestion for you, if you want to do the elementary row operations, do it step by step. Okay? Sometimes when you are trying to mix your steps, you're making mistake. So like for example, okay. So I'm doing these 2 steps at the same time. So okay, I will write just activate this, the first row. But the second row, I want to write R2 minus R1. But actually, you can also write R1 minus R2. Maybe different number, but still okay. The result should be the same. And maybe here, maybe you want to write 3R1 minus R3 like I did before, but I see the number is having minus. I don't like the minus part. So I'm decided to reverse this and then get this number. And then I get 0, 0. Okay, I can do more. Maybe I can do like maybe divide 3 or maybe this multiplied by 3 and then plus this. That's also fine. We can log in. Yeah, anyway, you can do many ways, but the more you are making the matrix, the more or less practice you are. So you need to also think how to approach the 0, 0, 0 faster. That's also what you need to think. And also another thing, maybe when you did like to find the 0, 0, 0, and then you don't make mistake, but you are making cycles, and you are ended up okay. Why this having a number again? That's also it is yeah, maybe you get the wrong idea in the middle, and then instead of 0, you get a number here. Then also you need to avoid. So try the same questions, try by yourself, and I also make another. I will attach another practice for you for the system equations for this augmented matrix, and hopefully you can try by yourself and see how long you can get the answer correct. Most of the case, this will be 3 variables. Most of the case, okay.
So I think that's all for today. Hopefully you get the idea for the augmented matrix.